Okay, in this video we're going to be calculating the empirical formula of a molecule from experimental data, and this is slightly different from the last example which I did, because in this one there's only one product and we've got two reactants, and we've only been given the mass. We've one of the masses of the reactants has not been provided. Let me just read out the question. 2.4 grams of magnesium ribbon burns in air to produce a white powder which has a mass of 4 grams. What is the empirical formula of the white powder? Okay, so the product is the white powder, and we need to work out the empirical formula of that powder. And we've been given the mass of the powder and the mass of the magnesium. So what we can do here is, since we know there's two reactants and two products, since it burns in air, and if something burns in air, usually the only thing in the air that really reacts with it is oxygen, especially here since it's burning, so it's a combustion reaction, so it's going to involve oxygen. Okay, so what we do here, first of all, what I'm going to do is I'm going to form a sort of semi-equation for this. And it's not a half equation, but it's a sort of equation which involves some of my variables that I've got here. So we've got magnesium. Magnesium has a symbol Mg. And we have the oxygen which it reacts with, which has O2 symbol. And this forms a unknown white powder. Let me just put some white powder. Yeah, there we go. There's a white powder. Anyway, so we've got 2.4 grams of this, and we don't know right now we don't know the mass of this, and we know that the mass of this is 4 grams basically, not 4, but yeah, 4.4 grams. And none of the mass actually disappears from this reaction. The mass on this side is going to be the same as the mass on this side. And because of this, because we know that the mass is not going to just disappear, we can do a simple subtraction to find out the mass of oxygen which participates in the reaction. So 4 minus 2.4, which gives us 1.6, and so therefore the masses of oxygen is going to be 1.6 grams. So now we know the masses of all three of these different substances which are involved in this particular equation. And for magnesium, we can use the periodic table to find out the mass, the molar mass of magnesium, of this magnesium, and we can find out the molar mass of the molecule of oxygen by multiplying the relative atomic mass by 2. So first of all, from my periodic table, hold on, I find that the relative atomic mass of magnesium is 24.3. 24.3. And I find that the relative atomic mass of oxygen is 16, and since this is O2, I'm going to multiply that 16 by 2, which is going to give me 32. And both the units for both of these are going to be grams per mole. Okay, so now we have the mass, and we have the molar mass. So we can use the simple equation: moles equals mass over molar mass. Number of moles equals mass over molar mass equals. Let me put my equal sign in there. Yeah, there we go. So now what we can do to find out the number of moles of each of these two, we can't find out this because we don't know the molar mass of this particular substance. So first of all, I'll work out the number of moles of magnesium. So let me use this new row here. Yeah, I'll use light green. Moles. So 2.4, which is the mass, 2.4 divided by the molar mass, which is 24.3, gives me 0.098 0.7. So anyway, so it's 0.098 or 0.099, and I'm gonna round this up to 0.1. So it was 0.098 or 0.099 to 3 decimal places, and I'm gonna round this up to 0.1. And for this one here, if I do 1.6 divided by 32, I get 1/20, which is 0.05. So I've got 0.05 moles of oxygen molecules and 0.1 moles of magnesium. So what I can do now is work out the molar ratios of the two elements, because these two elements are going to combine anyway to form this. So I'll just find out the ratio of elements, and to find out the ratio of oxygen atom, the amount of the moles of oxygen atoms rather than oxygen molecules, since there's 2 oxygen molecules in this, I'm going to just multiply this by 2, so which is going to give me 0.1 moles. And what we find is that there's an equal number of moles for both of these. So this is going to be mg to O, and the ratio is going to be 0.1 to 0.1, which is basically 1/10 with 1/10. So I'm going to divide both of these two sides of the ratio by 0.1, basically multiplying it by 10, and that's going to give me 1. So therefore the ratio is 1 to 1, and therefore the empirical formula is going to be MgO, and that therefore is the empirical formula of the white powder produced, MgO, 1 to 1. And that's basically how you'd find out the empirical formula if you had an unknown mass of one of the reactants, you had the mass of the product, you had the mass of one of the reactants, and yeah, and then, well, periodic table. There you go.